All right, let's look at the definition of a contingency table. So a contingency table is a table, and remember that a table is composed of columns and rows representing the numerical relationships between two characteristics in a sample or population. So for example, in the year 2000, a sample of 300 people were randomly chosen, and the sampled individuals were classified as to their age group and political affiliation. So characteristic one is their political affiliation. Do they register as Democrat? Did they register as Republican? Or did they register as independent? The second characteristic was by age group. Were they 30 years and younger, or were they 31 years old and older? So a contingency table for a sample like this, would be defined in columns, and the columns are going to be labeled by characteristic one, which is political affiliation, and in rows, which is labeled by characteristic two, which is the age group, right? The age group. So here we can see that across the top for our columns, we have characteristic one, which is political affiliation. So we have Democrat, Republican, and independent. And then down the side, labeling each row, we have characteristic two, which is our age group. So 30 years and younger, 31 years old and older. So what we can see by, how this contingency table is set up is, how many people registered as Republican that were 31 years and older. So if we look at Republican, okay, then it's going to be one of these two numbers in this column. But then we're also 31 years and older, then we would come over. Well, where's the intersection of being Republican and being 31 years and older? That would be 72. So in this sample of 300 people, 72 of them were registered as Republican and were 31 years and older. All right, so that's kind of how you put those two characteristics together. And so you can see we can take this characteristic, the political affiliation of being a Democrat, and we can figure out how many people in a sample of 300 registered as Democrat, and we can do that just by adding everything in the column. And so if we add 68 and 52, we get a total of 120. Now for Republican, we can add 56 and 72, and we had 128 people register as Republican. And for registering as an independent, we had a total of 52. And if we've done the addition correct, if we add these political affiliation totals, we should get the sample size. So 120 plus 128 plus 52 does add up to 300. And we can also go in a horizontal direction. So let's do it this way. So if we look at the age as being 30 years and younger, well, we had 68 Democrats that were 30 years and younger. We had 56 Republicans that were 30 years and younger. And we had 32 independents that were 30 years and younger. So if we wanted just to get a subtotal of the number of participants that were 30 years and younger, we would just add 68 plus 56 plus 32, and that gives us a subtotal of 156 people that were 30 years and younger. And likewise, we can figure out how many people were 31 years and older by just adding up all the values across this row and getting a subtotal. So that would be 144 people were 31 years and older. And just like what we did, we can also add down across the totals. And if we've done everything right, then 156 plus 144 should be equal to our sample size. And if you actually add those two up, they do add up to 300. All right. So, a contingency table you might think of as being like a hybrid table. You know, you can use these subtotals here to do some probability calculations. Now, a contingency table can be carved into events. So what do I mean by that? Let me take all of this here. Let me go ahead and just delete all that text. Okay. What I mean by carving this up? Well, what's nice about a contingency table is it starts to look like a Venn diagram. So if we look at just the contents on the inside of the table, okay, excluding these totals here on the outside. Let me do that a little bit better. So if we exclude these totals here, then what we've got is we could think of that as our sample space, right? Our sample space is going to be all possible outcomes. And inside this sample space, we can identify events. So let's say we had event R, and event R was being a Republican. Well, event R, we would draw it as a Venn diagram as being right here. That is event R. So we didn't kind of stipulate, anything about the age, just the event R being a Republican. Likewise, we could define maybe event 31. Let's see here. Let's maybe think of a better way to, yeah, I guess we could just write event greater than or equal to 31. Okay, and so inside our sample space, this would be event greater than or equal to 31. Right, so we can kind of carve this contingency table up into like a Venn diagram and draw events around these numbers. And now it starts to look a little more recognizable, like the probability problems that we've had, and we've drawn Venn diagrams for them. So, since we can draw events within a sample space, we can calculate the order of those events, right? So, for example, the order of event R, right? An event R is that the participant was Republican. The order of that is 128, because then that would be 56 plus 72. And that was this subtotal that we came up with here. How about the order of event greater than or equal to 31? Right? This event greater than or equal to, that should be a 31 right there. Well, that's the order of the greater than or equal to 31 event, and that would be 144. So you can use these totals, here along the side and along the bottom to give you kind of very quickly the order of certain events. The grand total, is the sum of all the row totals or all the column totals, and this is your sample size. So the order of the sample space would be 300. So therefore, contingency tables not only organize data to facilitate calculating probabilities, but to also present data in an easy to read format. So now that we have this basic definition of a contingency table, let's look next at an example about doing calculations of probability with these contingency tables. Okay, but let me know if you have any questions.